Now with a system, there are some properties that are worth understanding. I'm going to work on this a little bit, so bear with me. Again, I'm going to use some maths just to highlight some of the issues out of this. There's three key properties that we work with in plant wellness. The first one is the reliability of a series system can be no higher than the least reliable component. Again, I'll throw some numbers up here. 0.9, 0.8, so R1, R2. Chance of failure, 90% chance of failure, of success, 80% chance of success. That's all it is. It's just the chance this might or might not happen. So my system reliability, R system, is those multiplied together. 9 and 8 is 72, so my system reliability is 0.72, which is no higher than my worst. So if I've got a big lot of machinery in my process line, it says to me, if I want to improve my process results, I've got to find the worst performing machine and fix that machine. Because if I can push this up to 0.9, now I'm 0.81. Again, no higher than my worst, but I've improved the reliability. So when I do things like root cause analysis, when I look for a problem in my machines, I want to go to the worst machine, my top 10 machines, my top 10 worst machines, work on those to improve the business. Because it says very clearly, no point improving that one up to 1, perfect, when this one isn't touched. I'm going to work on the worst one. So in plant wellness, we're going to go looking for where the trouble is, the worst trouble, and solve that one first, because that is where the payback is for the whole system. Number 2 is if we add more items into a series system, say we've got a system of, we add one more to a system of 2 already, and each of those are 0.9 reliability. The reliability of all items must rise in equal proportion to maintain the system's original reliability. So if we have 0.9, 0.9, and I add in another one, 0.9. My system, 81, it's about 0.73. It was 0.81. It was 0.81. I've added one more thing in there, and as a system now, because all three have to work together, the system, of course, has reduced in reliability. If I want to get back to 0.81, I actually have to make all of these 0.93, 0.93, 0.93 to get back to 0.81. So I was at 0.81, I added something into the system, it dropped reliability. Now to get back to 0.81 where I wanted to be in the first place, I've got to lift all of these as well. So yes, I don't want to be adding things in. If I add things in, the chain gets longer with more links, and of course they're going to fail. And I think if I can go to the next, no, I haven't got that one there, wait a sec. No, haven't got that, that's okay. That's one of the slides I might add into this example. The third one is the one that's really, really interesting. What it says here, a small rise in reliability of all items. Say we're at 3 items at 0.93 and we go up to 0.95. We can lift each up to 0.95. The causes a much larger rise in system reliability. So let me just, now bear in mind I have no idea what causes this reliability to rise. Whatever it is that improves it is good to do. If we can do something, if we can go 0.95, 0.95, 0.95. If I can make that happen, increase reliability, then this one here goes to 0.86. This change is 2.2%. This change, I think, is 5%. Yeah. It says to me, hey, there's free money here. I put in 2.2% effort, I get 2.5 times return. Because I'm changing the entire system as one complete unit. And the mathematics is very clear. This isn't me making this up. The numbers are very clear. The proportionate rise at the individual component level is much less than the total delivery of the system. So the system improves a huge amount if I can create a global change. If I can create a global change across my company in one instant foul swoop, I will make absolute fortunes for very little effort. Question now becomes, what are the global changes that we can do that will do that sort of thing? Well, let's introduce precision maintenance. In the boardroom, the CEO's there with these execs, and we all say, guys, the company's now going to introduce precision maintenance. We saw before, if things are unstressed, if the stress is right down low at very low levels, we're going to create reliability. We're going to have far more cycles to failure than we had before. So the boardroom now does that, a global change. Let us introduce lubrication management. Every single gearbox, every single differential, every single hydraulic system, lubrication management. We're going to have world best lubrication management practices. Global change. Everybody gets trained up into proper lubrication management practices, good storage, no water contamination, removing wear particles, getting right down to very high quality conditions. So that decision across the years, every gearbox is protected, every hydraulic system is protected, every differential is protected, all by decision. So this is the stuff that that plant wellness works with. I don't want to do individual spot changes. I want to make a business-wide change. And very simply, we bring in world best practice. Because we already know what it is. We've known for 25 years what world best practice is. I'm going to bring it in as a strategy. Things like precision maintenance, lubrication management. I'm going to upskill my guys. I'm going to have multi-skilled guys. I'm going to have guys that can do mechanical work and a variety of other work as well. So I'm going to have guys that understand their machines very, very well. My operators, I'm going to make them into guys that can do minor maintenance, do TPM from Lean. Take the Lean TPM concept, going to introduce TPM across the company. My operators are going to be trained up to become very skilled minor maintainers of machinery. So yeah, to me, huge money very, very fast. Not little henpecks here and henpecks there. Bring in best practice. Because it's already been done. The answers are already out there. Just bring them in, buy them in. And that tells me I'm going to make a lot of money fast. And that's what I'm saying in plant wellness, hopefully no more than 3 years, hopefully within 2 years. You're going to get far better results because this equation and the concept is very clear. Stop doing things that don't work. Do the things that do work. Teach your guys to do the things properly, correctly. Buy the machinery in, buy the instrumentation if you need to, because the payback is a fortune very, very fast. So yeah, that's something that didn't come to me until I was 52 years old, until I began building the course and began playing with what this plotting actually says. In a series process, we have huge risk. Because if that goes wrong, system fails. That goes wrong, system fails. That goes wrong. I've got hundreds of things to go wrong. And I want to have none of them go wrong. How do I ensure none of them go wrong? Bring in world best practice across the whole operation. Then I'm going to get the right things happening, and the right things happening give me the right results, and the right results give me a lot of money. Thank you very much.